Hello students, welcome back to Botany first year's class. So till now we have finished the SAQs from the first unit and that is the living world and the biological classification and the plant kingdom. We have finished all the SAQs from these three chapters. Then we have finished the SAQs from the plant anatomy, that is the 12th chapter also over. And we have finished with the plant ecology, that is the 13th chapter. SAQs are also over. That means till now we have finished the here 3 chapters, there 2 chapters, 5 chapters were over. Now we will go with the 6th chapter SAQs. That is in the morphology, we have finished the LAQs. So from the 5th unit, that is the 5th chapter morphology in the flowering plants. From that chapter, we may get 2 VSAQs or 1 SAQ. That we cannot say. So we will see afterwards that VSAQs and the SAQs, that chapter. Okay. Now we will go with the 6th chapter, that is the modes of reproduction. Yeah. Now we will start with the 6th chapter, modes of reproduction. So in this, what are the questions we need to go? Because from this unit, that is the sexual reproduction unit, that is the 3rd unit we are having in the Telugu Academy, that is the modes of reproduction and the sexual reproduction in flowering plants. These 2 chapters will be there in that unit, where we will get 1 LAQ, that is from the 7th chapter. We have already finished that LAQs also, all the 5 LAQs from that chapter. Then we have to go with the SAQs. So from this chapter, SAQ from this unit only. The SAQs we can expect from the chapter 6 or chapter 7, because that is the 1 unit only, unit 3. So from the unit 3, we will have 1 LAQ, 1 SAQ, 1 VSAQ. So this VSAQ, they may give or not, no guarantee. Okay, but this SAQ and LAQ only from the chapter 7 we will get. That is the sexual type of reproduction. That is the embryo sac structure, microsporangial wall layers, process of fertilization. Okay, and the chasmogamous, the contrivances for the chasmogamous flowers to go with the cross-pollination only. How to stop, how they are stopping the self-pollination in them. After that, the pollinating agents of pollination. So out of these 5, 1 LAQ will be coming from the chapter 7. Chapter 6 does not have the weightage of LAQ. So from this chapter, SAQs only we have to prepare. Sometimes they will give from the chapter 7 only the SAQ also. We cannot say anything because this unit, what they have done in the March is this only. Okay, so from the unit wise, they are taking up the weightage. So not from the chapter wise. So from the unit wise, when we are saying, we cannot give the assurance that only chapter 6, we will get the 1 SAQ. So we have to prepare from chapter 6 and the chapter 7. Chapter 6 SAQs are also easy. Chapter 7, we will be having, once we learn the LAQs, we can write 3 SAQs as it is, because the LAQ part only there in the SAQ. So it's easy for us to go with the 3 SAQs. After that, we need to learn only another 3 SAQs that are there in the 7th chapter. Easy now. So like that, we have to make the things easy for us. Okay. Now we will go with the chapter 6 and how to write and remember the concepts in the chapter 6. So in the chapter 6, the first question is, Give a brief account on the gametogenesis with example. Gametogenesis means when the gametes were formed from the plant body. That is the origination, otherwise generation of the, otherwise production of anything we can say. Production of gametes. That is the gametogenesis, otherwise formation of gametes. Anything. Formation or production of gametes is called as the gametogenesis. So in this, what to write? If you know the gametes are produced from the plant body. Gametes means those are produced by the asexual reproduction or sexual reproduction. Whenever we'll have a doubt like that, just think that the gametes, male gamete, female gamete. But we won't say only the gametes during the asexual type of reproduction. Asexual type of reproduction, only spores are going to be produced. So with that, we can say that this is formation of gametes occurs only during the sexual reproduction. Isn't it? If we know this, then even we can write in our own words. No need to read the answer and mug up the answer. Like that, we have to prepare for ourselves. So, gametogenesis means production of two different types of gametes from the plant body is called as gametogenesis. So, these two different types of gametes, what are the two different types of gametes? Male gametes and female gametes are going to be produced. And these, after the sexual reproduction, during the sexual reproduction, whenever gametes are produced, which type of division occurs? How many gametes are there? Two types of gametes, male and female gametes. So for forming this male and the female gametes, which type of division occurs in the plant body? That's the reduction division. Reduction division occurs in the plant body. That is nothing but the meiotic division. Reduction division means meiotic division occurs. So the diploid cell becomes haploid cell by the meiotic division. So how many? 4. Okay. So here male gametes are also haploid, female gametes are also haploid. If we know this process, we can make the sentence over there. That's it. Okay. So here it's the gametes are haploid cells which are going to be produced by the meiotic division, and in the different organisms again different types of the sex organs are present. That means the naming of the male and the female sex organs is different in different organisms. If we are taking with the primitive organism, that is the algal members, in the algal members, the female reproductive parts are called as the archegonia and the male reproductive parts are called as the antheridia. Male reproductive parts. That is antheridia. Okay. Female reproductive part. That is archegonia. Archegonia. Now, this antheridia releases the male gametes. So, what are those called as, which are released from the antheridia? Antherozoids. And from archegonia, female gametes are going to be released. And these female gametes are nothing but the one single egg cell. one single egg cell will be present. So this is the one what we have to represent over here. Okay, we have to write. And the what we have to write after the definition of the gametogenesis. Gametogenesis means production of male gametes and the female gametes in a plant body is called as gametogenesis. And this gametogenesis, by this gametogenesis, haploid gametes are going to be formed by the reduction division that occurs in the diploid cell, and the female gametes and the in the primitive organisms, the male reproductive parts are called as the antheridia, which releases antherozoids, and the female reproductive parts are called as the archegonia, which releases a haploid egg cell. Okay, haploid egg cell. By the fusion of this, diploid zygote is going to be formed. Okay, so here, what is the example? What we can say for the antheridial and the archegonia? We know Marcantia, we can say. Otherwise, we can say the terrace, we can say. Otherwise, in the algal members, once we are saying, that is the Kara, we can say. Okay, otherwise, Kara. Okay, or else you can say the funaria, which is very easy for us to write, isn't it? So like that, we can give the examples. And in some organisms, the gametes are completely looks alike. Male gametes and the female gametes are looks alike. That is the homogametes, homogametic condition. When the male gametes and female gametes are looking alike, that is called as the homogametes. Otherwise, isogametes. When male and female gametes are looks alike, that is the isogametes. Example, cladophora. Example, cladophora. Okay, next one. And heterogametes means when the male reproductive parts and that is the male gametes and female gametes can be distinguished with their size and the shape. That is called as the heterogametes. Example, Kara. Otherwise, we can say the Marcantia, Funaria, Terrace, Cycas, any plant we can say. Okay, not the angiospermic plant. The gymnosperms and the pteridophytes, bryophytes, we can say, not the angiospermic plants. Now, after this, how these gametes are formed? So, they are asking an account of the gametogenesis. So, and that we have to give which type of cell division occurs for the formation of the gametes in the plant body. So, here the gametes are the gametes in the maximum organisms are the heterogametes. Maximum organisms, it is having the heterogametic condition. That is, male gametes and the female gametes are different. Can be distinguished easily. That is the heterogametic condition. And in this parent plant body, in this type of plant body, what happens? The haploid cells are formed with by the meiotic division. The haploid gametes are formed by the meiotic division of the diploid meiocytic cells. Okay, and this haploid, and sometimes the haploid parents will be present. The parental body is haploid. Then also they will produce the meiotic division. They will produce the gametes or the haploid, and the meiotic division occurs over there. Okay. See, a haploid parent produces gametes by the meiotic division, because always the gametes which are formed from the cell, that cell should be the diploid mother cell. Diploid mother cell. This only undergoes meiosis to give the haploid gametes. This is mandatory stream in the plant body. There is no change in this. Always the mother cell is diploid, 2n in condition. The haploid gametes are always n in condition by the reduction division, that is the nothing but the meiosis. The same one we are saying over here. Okay. And this type of haploid body will be present in which type of organisms? In the Monera, in the organisms, Monera, fungi, algae, and bryophytes. Okay. Monera, fungi, algae, and bryophytes. Monera, fungal organisms, and algal members, and the bryophytes. In them, the initial plant body is a haploid. Initial plant body is a haploid. And these haploid plant bodies will produce haploid gametes only by the meiotic division of the spore mother cell. Okay. So this is the one what we have to save over there. But in the another organisms, in the other organisms, that is the pteridophytes, gymnosperms, and the angiosperms, the initial plant body is diploid in nature. In the pteridophytes, gymnosperms, and angiosperms. In all these ones, the initial plant body is of diploid. Then they will undergo the, anyway, they will undergo the reduction division to form the haploid plant bodies, haploid gametes. Okay. And once the plant body is haploid, then they will make the gametes with the mitotic division, and then the meiosis occurs after the zygote formation to make a haploid plant body. Okay. Like that, the complete division will be there. So the meiocytes, the specialized cells are called as the meiocytes. Meiocytes means mother cells, gamete mother cells, which undergo meiosis are called as the meiocytes. The cells which undergo meiosis are called as the meiocytes. So in the diploid organisms, the mother cell will undergo meiosis to form the haploid gametes. When the plant body is haploid, then they will undergo the mitotic division to form the haploid gametes. Then these haploid gametes, male and the female, will fuses to form the diploid zygote. Then this zygote undergoes meiosis to make plant body of haploid. Okay. So this is the one what we have to write in the given account of the gametogenesis. So what we have to write in this gametogenesis means what? What we have to write? Gametogenesis means when the gametes are formed from the plant body by the reduction division is called as the gametogenesis. And this gametogenesis, through this gametogenesis, male and the female gametes are formed, and in some organisms, the male gametes and the female gametes look alike. That is the isogametic condition. That is called as the isogametic condition. Example, isogametic condition. Example, cladophora. Example, cladophora. In some organisms, the male gametes and the female gametes are different. So that is called as the heterogametic condition. In the heterogametic condition, the gametes are produced in a different parts. Okay, in antheridia and in the archegonia. Example, algae, fungi, kingdom Monera, and bryophytic organisms, where we will see the gametes are heterogametic, and these gametes are produced in the haploid organisms. The gametes are produced by the mitotic division. Then these two gametes will fuse together to form a diploid zygote. This zygote undergoes meiotic division to form haploid plant body. And in the diploid organisms, the gametes are formed by the reduction division only. Then these gametes are haploid, and these are going to be having the different shapes. Okay, so that is, and these mother cells which will undergo meiotic division are called as the meiocytes. This much you have to write. Okay, and at the end we have to give the one tag. In the life cycle of any organism, meiosis occurs only once. So for the haploid organisms, whenever they are making the gametes, that is by the mitotic division, and the zygote undergoes meiosis to form a haploid plant body. And in the diploid organisms, meiosis occurs before the gamete formation. Then these gametes fuses to form a diploid zygote. Zygote undergoes a mitotic division to form a diploid plant body. This much we have to write and end up this. Okay. And the next question is give an account of the sexuality in organisms. Sexuality in organisms. So what is meant by sexuality? That is the male and the female sex organs formation in the plant body. So here the production of the male and the female sex organs for going with the sexual reproduction is called as the sexuality in the organisms. And these are and whenever these sex organs are formed, they will make the gametes formation. That is the male gametes and the female gametes. And these two gametes will fuse to form a diploid zygote. Okay. Sometimes these gametes are produced from the same individual, otherwise from different individual. That is male thallus and the female thallus. Otherwise, male organism, female organism are different. So here some plants will be having both the male and the female sex organs on the same plant. Male and female sex organs, sexual reproductive organs are on the same plant. That is the bisexual plants. The plants are called as the bisexual. Bisexual means when the male and the female and male sex organs are present on same plant. That is called as the bisexual plant. Okay. And if they are present on two different plants, that is the unisexual plants. But in some organisms, in example, in fungi and in some plants, the sex organs are present on the same organism. So that is the homothallic. In some fungi are the homothallic. Homothallic. Okay. And homothallic means on the same plant, both the sex organs, on the same organism, both the sex organs are going to be seen. And monoecious. and the plants are the monoecious. Fungi only we will call it as a homothallic because the fungal body is called as a mycelium. So homomycelium we cannot say. That is a homothallic only we can say. Don't get confused. The thallus means undistinguishable plant body. Okay, primitive organisms are having. But for the fungal body, we will call it as a mycelium. But here we will call this fungal organisms which are having the both the sex organs on the same fungi. That is a homothallic. Okay, and for the plants, we will use the word as the monoecious. Monoecious. Monoecious means when the both the sex organs are present on the same plant. Male and the female sex organs are present on the same plant. That is called as the monoecious type of condition. Okay. And these are used to having the, they are having the both the sex organs on the same plant means there is a bisexual condition, what we can say. Okay. And heterothallic. Okay, some fungi are heterothallic and they can be, they are the dioecious, and some plants are the dioecious. Heterothallic means two different thalli are present, thallus are present, where male thallus is different, female thallus is different. And some plants are like that. Male plants are different, female plants are different. Example, papaya, where male plant is different, female plant is different. So only the fruits which are occurring on the plant, that plant is considered as a female plant. And the another plant where no fruits, that is a male plant. Okay. So like that, the plants are the dioecious. That means two different plants are present where the we can separate the plants with their sexes. That is the male sex organs and the female sex organ. That's the one what we have to write. And the male flowers, unisexual male flowers are called as the staminate. Unisexual male flowers are called as the staminate. If you remember this word, you can write. Otherwise, you can simply say unisexual male flowers. Okay. And the female flowers, only female flowers are called as the pistillate flowers. Pistillate flowers. Only the female sex organs are present in those flowers. Okay. And the next question, what we have to say is the fertilization is not an obligatory event for forming the fruits. So explain this statement. Fertilization is not an obligatory event for the fruit production in certain plants. Explain this statement. For the fruit production, what we need, we want the fertilization has to occur in the flower, in the female sex organ, that is in the ovary. Then only the fertilization can be done. Okay, so in some plants, fertilization means the whenever the male and the female gametes are fused to form a diploid zygote, that is called as the fertilization. And this fertilization is the most important one to turn the ovary into fruit and ovules into seeds. After the fertilization, ovary turns into the fruit, ovules turns into the seeds, and calyx, corolla will wither off. Okay, that is the petals and sepals will wither off. Wither off means fall off. Then androecium, that is the anthers and the filaments will wither off. Okay, fall off. Only the style also goes off. Style and the stigmatic lobes. Only ovary will be present. which is turned into the fruit after the fertilization, and the ovules inside that turns into the seeds of the fruits. Okay, this is the most important one. In some plants, the without the fertilization, the fruit starts development. That is, the flower turns into the fruit without a fertilization. That is called as the parthenogenesis. Parthenogenesis. Without a fertilization, when a fruit is formed from the ovary, that is called as the parthenogenesis. And in this, without a fertilization, when we are saying, what happens over here? The male gametes and female gametes never fuses. So when they never fuse, the ovules cannot turn into the seeds. So the parthenocarpic fruits does not have seeds. Seedless fruits. What we'll call them as the seedless fruits. Okay, and this parthenocarpy is the naturally occurring one in some plants. Example, banana. In banana, we will see the naturally occurring parthenocarpy. Okay, so these are the seedless fruits. And in some plants, we will induce, that means we will make the flowers to go without a fertilization to develop into the fruits. That is inducing, what we'll say. We are making them to go with the fruit formation without a fertilization. That is in some plants, the artificially induced parthenocarpy can be seen. Okay, so that is in that also seeds are not there. Example, grapes. Okay, so this is the one. So by seeing of this, we can say fertilization is not necessary for the fruit formation in some plants. In certain plants means only in some plants, fertilization is not necessary to make a fruit from the ovary. That is the one what we have to say. So what we have to write over here, what the first statement. In some plants, the fruits are formed without fertilization. Okay, and in this, the male gametes never fuses with the female gametes to form a diploid zygote, but the ovary turns into the fruit and the ovules never turns into the seeds. So that is called as the type of fertilization, and the fruit formation is called as the parthenogenesis. And whenever the ovules never turns into the seeds, the fruits are the seedless fruits. Example, banana. In the banana, the naturally occurring parthenogenesis can be seen. And in some plants, we can induce the parthenogenesis. Example, grapes. For the commercial process, we will induce the parthenogenesis. And in all other plants, parthenogenesis, the fruit formation occurs by the fertilization, by the formation, by the fusion of the male and the female gametes. Then fruit and the seeds are going to be formed. That is the true fertilization and the true fruit. Okay, like this we can end up this answer. And the next one is, so this also I have discussed when we have discussed this parthenogenesis. This question is important, what we discussed now. Fertilization is not an obligatory event for fruit production in certain plants. Explain. This one we can expect now. And the next one is list out the changes observed in angiospermic flowers subsequent to the pollination and the fertilization. That means during the pollination and fertilization, what are the changes that occurs in the flower? What we have to say. Just now I explained it during this process, isn't it? Same thing we have to list out over here. After the fertilization. So after the fertilization, what happens? And before the fertilization, what happens? After the fertilization, the sepals, petals, and the stamens will wither off. And the style and the stigmatic lobes of the female part, that is the gynoecium, will wither off. Only the thalamus and the ovary will be present on the for the flower. Thalamus and the ovary after the fertilization. Style, stigmatic lobes, and the filaments and the anther lobes, petals and sepals, everything will wither off. Wither off means fall off. Okay, wither off or fall off from the plant body. But in some plants, okay, but in some plants, they will be the petals, the sepals will be present after the fertilization process also. Example, brinjal. In this, what happens? The sepals will be present after the fertilization. After the fertilization. So this is called as, this type of sepals that are present after the fertilization are called as the persistent calyx. Persistent calyx. Persistent calyx. Okay. Like this, we'll see the brinjal na, which is having the green colored calyx. That's the persistent calyx, what we are saying. And one more example also, chili. Chili is also having the calyx that is attached after the fertilization. Capsicum. So this is the persistent calyx, what we have to write. In some plants only this type of calyx presents. In other plants, the calyx corolla will wither off, otherwise fall off. Okay, so we need to go with the specific words over here. And the zygote develops after the fertilization, zygote is going to be formed, and this is zygote metamorphosis. Okay, zygote metamorphosis. That means with the gradual changes in it, it develops into, it turns into the embryo. Okay, and after this, the ovary turns into fruit, and ovules into seeds. Okay, and the pedicel, otherwise the peduncle, turns into the peduncle of the fruit, that is the stalk of a fruit. Okay, so like that we have to say from the pollination to the fertilization process, how the changes occurs in the plant body. Now comes with the one more important question, that is the define juvenile phase and the reproductive phase. You can see from your readers, otherwise the materials. And here we have written the definition and one sentence explanation, 4 marks we will get. What is meant by juvenile phase? Juvenile phase is also considered as the vegetative phase. Juvenile phase is also considered as vegetative phase. That means the first part, the first life of the plant body, that is called as the vegetative phase. In that, the growth and the maturity of the organism can be seen, which is which is going with the sexual reproduction by the formation of the different organelles in it. That is called as the juvenile phase. When the growth of the organism occurs by the formation of the sexual organs in them to go with the sexual reproduction, that is called as the juvenile phase, otherwise the vegetative phase. Next comes the reproductive phase. Reproductive phase means where the plant body is developing the reproductive organs in them, which will go with the reproduction, that is a sexual reproduction and the asexual type of reproduction, that is called as the reproductive phase. And in this, different changes will occur and the duration will be different in different organisms for that reproductive phase. In some plants, it will be taking nearly 3 to 4 years, 3 years, maximum 3 years. Example, pine trees. Okay, because in that the female flower, only female cone, what we have to say, that will be taking 3 years for its gradual development. After that only the fertilization process will occur in that. So 3 years is the very long duration for that sexual type of reproduction. So that's the one we are saying. The reproductive phase is a different in different organisms. In some plants, it's a very short period of time, and in some plants, it's the maximum period of time. Okay, that's the one. And here we are not discussing for the animals, only the plants we have to talk about it. And don't give the animal examples at any cost in my subject. Make sure this. No animal description and the examples. That's a mandatory stream. Because here we are saying it as a botany subject. That means study of plants, not the animals. So don't give the examples with the animals. And the explanation for the plants and examples with the animals. And whenever you are saying the veins and the blood and everything in your process of writing the answer, then the answer is completely strike off. We won't give a half mark also for the theory, because you have written the part with the animals, considering with the animals, the blood, veins and the bones and everything. Those are not seen in the plants. So don't write all that nonsense stuff. And next one, somewhat important question. That is the distinguish between the asexual and the sexual reproduction, and why vegetative reproduction is considered as a type of asexual reproduction. So in this 2 questions they ask. One is the vegetative reproduction, asexual reproduction, and the sexual reproduction differences. And then they ask with the why the asexual reproduction is considered as the sexual type of reproduction. So in that, what we have to write? The first one will be the differences between the asexual and the sexual type of reproduction. So asexual reproduction, for the formation of the asexual reproduction, one single parent is sufficient. For going with the asexual type of reproduction, one single parent is sufficient. And sexual reproduction considered with the commonly occurs between the 2 parents. 2 parents are needed for going with the sexual type of reproduction. Okay, and in the asexual reproduction, homogametes formation is seen. That is the both the spores that are formed during the homosporous, not the gametes. Homosporous condition can be seen in the asexual type of reproduction. In the sexual type of reproduction, heterogametic formation is common. And in some plants, homogametes are also formed. Example, cladophora. Okay. And here, gametic fusion, gamete formation is not seen in the asexual type of reproduction. Gamete formation is seen in the sexual type of reproduction. And in the asexual type of reproduction, what we have to say, the gametic fusion never occurs. And in the sexual reproduction, gametic fusion occurs between the male and the female gametes. And here, zygote is not formed, which is a diploid in nature. And the diploid zygote is formed during the sexual reproduction. And the offsprings which are formed after this reproduction, all are same, looks alike. That is, the identical offsprings are formed. Identical offsprings are formed during the asexual type of reproduction, and non-identical offsprings are formed in the sexual type of reproduction. Okay. And the asexual type of reproduction is faster than the sexual type of reproduction. And what we have to see is another question. Why vegetative reproduction is also considered as a asexual reproduction? The vegetative reproduction, for going with the vegetative reproduction, what is meant by vegetative reproduction? From the single plant, if another plant was made, is called as the vegetative reproduction. From the vegetative parts of the plant body, if a new plant is going to be made, that is called as the vegetative reproduction. So in this also, the two parents are not necessary and no gametes are going to be, gamete formation cannot be seen. Then, and in this vegetative reproduction, from the single parent, many offsprings, and in a less duration, we can get the new plants, otherwise the next generation. So with that, we can say vegetative reproduction is also considered as the asexual type of reproduction. This much we have to say. Again, the same question we will be having. Okay, next comes identify each part of a flowering plant and write their haploid or diploid condition. That means N and the 2N condition we have to write. So here, first of all, go with the order. Ovary. Ovary is always diploid in nature. Okay. Ovary is always diploid, 2N in number. Next one, anther. Anther is also diploid in nature, 2N in number. Next one is the egg cell. Egg cell is always haploid in number. Egg is always haploid in number. Pollen grain. Pollen grain is also haploid in number, because these will be formed by the meiotic division, reduction division, though haploid in number. Next comes the male gametes. Male gametes is always haploid. When pollen grain is haploid, male gametes are also haploid. No chance of becoming the diploid over there. Okay. Next one, zygote. Zygote is always diploid by the fusion of the male and the female gametes, diploid in nature. Antipodals are haploid by the formation of the meiosis, by the occurrence of the meiosis. Megaspore mother cell. Mother cells are always diploid in nature. So that is the diploid condition. If we have written this down, this means the haploid and the diploid condition, then we will get 4 marks. Like this also, we can expect this supply exams, because this is the easiest one and maximum students will score good marks and few again will do the mistakes in the simple questions also. Haploid, diploid. If you put the brain over there, then easily we can go with the haploid and the diploid conditions. Okay, so don't get confused and be prepared with all these questions, what we have finished off till now, and we will continue with the next SAQs from this chapter, and from the 8th chapter we will start. Okay, so that it's easy for you to cope up with the maximum SAQs. Okay, right? So stay tuned to the same channel, same time for the next upcoming 8th chapter SAQs, right? Thank you.